How we doing, pre-calculus folks? What we're going to talk about in this video is we're going to begin talking about what are called piecewise functions. Okay, a piecewise function. Now, unlike other kinds of functions, piecewise functions they're not their own family of function. A piecewise function is like a variety bag. Okay? A piecewise function is basically, sometimes I call it a Frankenstein function. Because when you think about Frankenstein's monster, you know, he was this monster that was pieced together with pieces of people, right? And then brought to life, so, you know, supposedly, right? Or in the fictional story. All right, so look, what we do here with piecewise functions then is we take a function, and what we do with the function is we piece it together with pieces of functions. Because there's no way of actually creating a single defined function where it actually behaves with these with all these outputs given certain inputs. We call it a piecewise function, and we piece together different kinds of functions, and then we say when over what x values those pieces are relevant. Okay, so what we're seeing here is this. This function, if you were to plug a number in before you could actually find out what the output is, before you could plug it in for one of the x values, you have to first find out where you should plug in the number. So for example, if you're plugging in a number between -5 and up to 2, but not including 2. Why aren't you including 2, Mr. Ryan? Because this does not say or equal to. This says when x is greater than or equal to -5 and less than 2. If you wanted to plug the number 2 in, you would go down to this next one where x is greater than or equal to 2. And you would not plug 8 in here because this says where x is less than 8. If you wanted to plug 8 in, you would plug it into this bottom piece here where it says x is less than or equal to 8. And I'm pretty sure I made a mistake here because I meant to make this x is less than or equal to 10. So this piecewise function only has a domain that begins at -5 and ends at 10. So if we come to this function and we want to know, for example, what is f of 12? Well, we have a problem here because 12 is not included in the domain for any of the pieces. Therefore, this function is undefined for an x equal to 12. All right, so we can't plug in any x values that are not on the given domains of the pieces. But if we did want to plug in a number that is on the domain, we would plug it into the appropriate piece. So for example, if you wanted to know what f of 4 is, you would go to the piece that has x equals 4. X equals 4 is not on this domain. X equals 4 is on this domain because 4 is between 2 and 8. And therefore, actually this could be a little confusing. How about let's say f of 3? Because the answer is 4. I don't want you to think that the answer is always the same as the input. All right, so 3 is not on this domain. It is between 2 and 8. So when x is 3, the answer, we're going to plug 3 into this function over here. Well, that's a constant function. There's nothing to plug it into. When there is nothing to plug it into, whatever number is there, that's your answer. So what number do you see here? 4, therefore f of 3 is equal to 4. Also, if you were to plug a 7 in, the answer would be 4. If you plugged a 5 in, the answer would be 4. If you plugged a 2 in, the answer would be 4. Okay? So that's how this is what we call a piecewise function. Now, what we want to do here is we want to graph this piecewise function. And to graph a piecewise function, just to give you an idea, you don't have to do this, but to give you an idea, what you may want to do is mentally break up the coordinate plane into its pieces. We know that the first piece is only going to go from x equals -5 up to x equals 2. And so we're going to go here, the coordinate plane, -1, -2, -3, -4, -5. Okay, so that's right about here. Up to +2, which is right here. So we know that this piece, we are only going to graph the graph of x plus 2 from here to here. Now, if we were to graph x plus 2, this is a linear function. It has a y-intercept at +2. Let's use a different color. Let's use green. Nope, let's use blue. All right, so we'll go to +2 and we'll put a dot. It has a slope of 1, and so therefore we would have a slope of 1, right? And this is what x plus 2, or the graph, I should be using a straight edge or something, looks like, right? This is x plus 2. However, here's the problem. We only want the graph to go from -5 up to +2. So we have to go over here to -5, and anything less than -5 we have to get rid of, because those values are not on the domain of the function. And then over here, when we get up to +2, we have to stop the line. And so this, what you're now looking at, this little piece of a line, hence piecewise function, this piece of a line is a part of the graph of this piecewise function. Now, when we get to this interval from 2 up to 8, well, that starts here at 2 and goes up to 3, 4, 5, 6, 7, 8, goes up to here. That's going to be the graph of f of x is equal to 4, or just y equals 4. So we're going to go to 4. 1, 2, 3, 4. Starting at 2 and ending at 8, which will be right here, we're going to draw a horizontal line at 4. And that's just a piece of the function. Now, the last piece of the function is -3x plus 28, and it only goes from 8 up until 10. All right, so that's from 8 to 10. So that's from 8 up to 10. So it's only a little piece, right? Now let me show you how to find this piece. One way that you can do this, this is a linear piece, and what I'm about to show you, you can really only do with a linear piece, okay? Here's what you do. Plug both of these numbers, one at a time, into the piece of the function. So we'll plug 8 in, -3 times 8 plus 28. -3 times 8, that's -24, plus 28, that equals +4. And that means the coordinate 8, 4 is on this piecewise function. So we're going to go to 8 and 4, 1, 2, 3, 4, put a dot. Then we're going to plug the 10 in. All right, let's plug in the 10. And we have -3 times 10 plus 28. Well, -3 times 10, that's -30, plus 28, that's equal to -2, right? So we know that the coordinate 10 and -2 is on this piece of the function. In fact, it's at the other end of the piece. 10 and -2, so we're going to go to 10 and -2. And now what you can do actually is you can just get a straight edge and you can connect these two dots. So we'll go there, we'll connect these two ends, and we will draw our piece of a line. And so now what we just did was we just drew our third piece, and now this is the graph of this piecewise function. Let's do another example, okay? All right, here we have another piecewise function. This one has 4 pieces. Here are the domains for each one of the pieces. Okay, so this piece, -2x minus 6, only runs when x is -6 up to -1, but not including -1. -1 is included on the next piece because it's got the or equal to down here. So the next piece, x minus 3, as x runs from -1 up to 2, and then -1, this is a constant function. It's going to be flat again because it doesn't have an x in it. It's going to be flat at -1, and that runs from 2 up to 5, but not including 5. And then the last piece here runs from 5 up to 10, and it's the graph of -x plus 4. So we have 4 pieces, 4 little pieces that we're going to kind of put together like a puzzle. And after you put the 4 pieces together, it's going to have a strange shape to it, but that's going to be what the function is. So let's go ahead and graph it. All right, let's see here. Let's start with this piece here. So what I want to do now is I want to do it a little differently. I want to show you a way that you can consistently graph these correctly. Now this will only work if it is a linear function. This is linear, this is linear, this is technically linear, and this is linear. I mean, this is a constant function. It's a flat straight line. It's got a slope of 0. All right, so look, what I'm going to do is I'm going to plug each of these numbers, the beginning number and the end number, into the function and get the output value. So if I plug -6 in here, I would get -2 times -6 minus 6. -2 times -6 is 12, minus 6 is equal to 6. And so this graph, this piece, has the coordinate -6 and 6. Now I'm going to plug in -1. Let's plug -1 in. And when we plug -1 in, -2 times -1 is positive 2, minus 6. 2 minus 6 is -4. And so the other side of the piece has the point -1 and -4. So I'm going to go ahead and plot these two. I'm going to go to -6 and 6, -1, -2, -3, -4, -5, -6, and 6. 1, 2, 3, 4, 5, and 6. So right here, I'm going to put a dot. Then -1 and -4. So I'm going to go to -1 and 1, 2, 3, 4, -4, and I'm going to put a dot. Okay? Then I'm going to connect those two dots with a straight line. Now, if this piece was a quadratic, or if it was a radical function, or a rational function, or an exponential, anything not linear, then I could not use a ruler to make a straight line. I'd have to do something different to find out the shape in between. But it is a straight line, so I'm going to put these two together. That looks about right. And I'm going to draw a line. Now notice, I am stopping at the points. Notice that I am not going beyond this point backwards, and I am not going beyond this point forward. That's because this piece is only in existence. It is only valid from -6 up to -1. Okay? Now, technically down here, do you see this dot? Technically, because it doesn't include this point, I should put an open circle because that point is not included on this piece. However, if that point is included on the next piece, then I would fill in the hole. Okay? All right, so now let's do the same thing for this next part here. Let's plug -1 in, and then let's plug 2 in. If I plug a -1 in here, -1 minus 3 is equal to -4. So I have the point -1 and -4, which happens to be the same point. So it is going to get filled in. This hole is going to get filled in. All right, now I'm going to plug a 2 in. Plug 2 in. 2 minus 3, well, that's -1. And so we have the point 2, -1. 2, -1. And because it is a linear function, I can draw a straight line between the 2 points. So I'm going to plot the point -1, -4. -1, -4. Let's go ahead and fill that hole in. And then I've got the point 2 and -1. So I'm going to go to 1, 2, -1. That's right here. And I'm going to draw a straight line between them. There we go. It's a little off, but it'll do. That's a little bit better, but not that much better. All right, cool. That's close enough. All right, so now let's do this third piece. From 2 up to 5. Well, we can't really, I mean, there's no x here to plug into. It's just -1. That makes it a constant function. That means it's flat at -1. So I'm going to draw a flat line from x equals 2 up to 5, sideways, at the height of -1, which happens to be where this ended. I would have put an open hole here, right? This would be an open hole because the second piece does not include 2. But because the third piece is picking up right at the same place, I can go ahead and leave it there. And we're going all the way up to 5. So this is 2, 3, 4, 5. And so here we would have, I would put, let me go ahead and, just to be technically correct, let me go ahead and put an open hole or an open dot. Now I'm going to draw a horizontal line. And now, lastly, we're going to do this last piece. Running from 5 to 10, let's plug 5 in here, and then we'll plug 10 in here. So if I plug a 5 in here, I have -5 plus 4. -5 plus 4, well, that equals -1. Convenient. 5, comma, -1. Well, that's right here. That's this point where we put a hole. It's 5, -1, so let's go ahead and close that hole in. All right? And then we're going to plug a 10 in, and we get -10 plus 4. So -10 plus 4 is -6. Okay? So we now have the point 10 and -6. So let's go to 10, -6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and -6. -1, -2, -3, -4, -5, -6. Ta-da! Put a dot there. And then connect it with a straight line, because this is a linear, this piece right here is a linear function. Okay? So we'll grab the straight edge here, okay, line up these lines, and we will draw there. And now, this crazy looking graph here that has these sharp corners and stuff and all these straight lines, that is the graph of this piecewise function. Okay? So that's how you graph a piecewise function. What we're going to do next on the next problem is I'm actually not going to give you a piecewise function that we're going to graph. I'm going to draw a graph first, and then we are going to interpret the graph into a piecewise function. All right, folks, here's what we have. We've got this graph here. It looks like it's in 1, 2, 3, 4 pieces. So here's the first thing you can do when you have all these pieces. The first thing you can do is identify the intervals of the pieces. So that means we're going to do the right side first before we do the functions themselves. Okay? We can see that this piece right here that runs from here to here, what is the start? Now we're looking for x values here. Right now we don't care about y values. We only care about x values. Okay? Although, you know what would help is to go ahead and put the coordinates of all these points on here. So what's the coordinate of this piece here, or of the end of this piece? -1, -2, -3, -4, -5, 1, 2, 3, 4, 5, 6, 7, 8. So this is at -5 and 8. That'll help. This point here is at -2 and -1. This point here is at 4 and 3. This point right here is at 6 and 3. And this point here is at, let's see, 6, 7, 8, is at 9 and 0. 9 and 0. Okay? Now that we have those points, because these are all straight line pieces, we could actually use what we know about writing the equation of a line. We could use point-slope form or slope-intercept form or something like that. I prefer point-slope form, but you could still do it with slope-intercept form. We would have to eventually turn it into slope-intercept form, but let's not get ahead of ourselves yet. Let's go ahead and let's identify our intervals, our x intervals. This first piece starts at -5, okay, and it goes up until -2. So here's what we'll do. We'll make room for our pieces. Let me draw some lines here, and I'll make sure that we stay in line because we got to make room for 4 pieces. There we go. So we'll put 1 piece here, 1 here, 1 here, and 1 here. That's 4 pieces. And over here on the right side, we'll say that this function runs from -5, and it's a dot. It's an open circle, so it's going to be less than or equal to, or the x is greater than or equal to -5. Now here you may say, well, we're going to put a -2 here, but Mr. Ryan, should we put a less than or equal to, or should we just put a less than? It is a closed circle, so we could put less than or equal to, but we could also put less than as long as we put the or equal to on the next piece. What you should not do is you should not put less than or equal to here and then do less than or equal to here. You should not put the or equal to on both pieces. You need to pick one. And in my opinion, it doesn't really matter which one you pick. So you decide. I usually put it on the next one down, but that's just my personal opinion. And maybe I'm an idiot for choosing that, but it doesn't really matter, at least not to me. Okay. All right, so you can have your own way of choosing. And there are other situations where it really does matter, but in this particular case, it doesn't. All right, so now the next line here is going to run from -2 up until 4. Okay? So we know that it's going to run from -2 up until 4, so I'm just going to say less than 4. But then on the next piece, I'm going to say 4 is less than or equal to, because these are all closed circles. I'll put an X. And now we know that this piece is starting at 4 but ending at 6. So we'll go from 4 up to 6. This last piece here goes from 6 up until 9. And so I'll put 6 less than or equal to X. Now this last one, I am going to put an or equal to because it's at the end and that's a closed circle. So we're going to include or equal to 9. Now that I have my 4 intervals, now I have to find out what the graphs are. So what I'm going to do is, the first thing I'm going to do is I'm going to identify the slope of this graph, or of this first piece. Okay, because it's a linear function, so I know that it's going to be something like y equals mx plus b. Or, well, I'm not going to put the y is over here. So I'm going to put mx plus b here, but I got to put in the slope and the y-intercept. I can't put point slope form in here because it can't be y minus 5 equals, because I have my y equals way over here on the outside of the piecewise function. Then I have the bracket. So here I can't put a y in here. It has to only be x variables. So I can't do point slope form. But I can start with point slope form and then convert it into slope-intercept form. Now, I can find the slope of this function in one of 2 ways. I can either do it graphically by counting down and over, or I can do my y2 minus y1 and use my points -5, 8 and -2, -1. I'm going to go ahead and use the slope, or the y2 minus y1 form. All right, so I'm going to start with y2, which is -1, minus y1, which is 8, over x2, -2, minus x1, which is -5. And that'll make this plus 5. So -1 minus 8 is -9. -2 plus 5 is 3. -9 divided by 3 is -3. So my slope of this line is -3. So I'm going to write -3 x. And now, here's the thing. I could follow the line and find out where it would cross the x-axis, or the y-axis. But what I'm going to do is I'm actually going to write it temporarily in point slope form. I'm going to use this point -2, -1. So in point slope form, I'm going to have y minus -1, or plus 1, is equal to the slope, -3, times x minus -2, or plus 2. Now I'm going to solve for slope-intercept form. Distribute my -3, and I get y plus 1 is equal to -3x minus 6. Then I'm going to subtract 1 from both sides, and I get y equals -3x minus 7. And so this is the equation of that piece, -3x minus 7. I'll put a comma on there, and now I'm done with my first piece. My second piece, I'm basically going to do the same thing. Only this time, you know what, let's go ahead and let's identify the slope graphically, okay? If I look on here, I'm going from this point up to this point. So I'm going up 1, 2, 3, 4, and over 1, 2, 3, 4, 5, 6. So that's 4 over 6. So my slope is 4 over 6. Well, 4 over 6, that reduces to 2 over 3. So I know my slope is 2/3. Okay? Now, if I look here, I can see that the y-intercept is a little weird, and it's hard to see graphically. So I think what I'm going to do is, again, I'm going to do point slope form. Only this time I'm going to use the point 4, 3. So we got our slope of 2/3. In fact, I'll put up here, I'll put a 2/3 x. There we go. So y minus the y value, which is 3, is equal to 2/3 times x minus the x value, 4. There we go. Now, to turn it into slope-intercept form, I'm going to distribute my slope. So I'm going to have y minus 3 is equal to 2/3 times x is 2/3 x. 2/3 times -4 is -8 over 3. That may look a little messy, but it's just, you can deal with fractions. It's not that bad. Now we're going to add 3 to both sides. Add 3 to cancel on this side. But over here, instead of adding 3, I want to add 3 with a denominator of 3. Well, what's equal to 3 but has a denominator of 3? Well, 9 over 3, right? 9 divided by 3 is 3. So I'm going to add 9 over 3. And so now, -8/3, -8 over 3 plus 9 over 3, well, that's equal to 1 over 3, 1/3. So that's my y-intercept is 1 over 3, positive 1 over 3. So this is going to be 2/3 x plus 1 over 3. And you can rewrite this, you could write this as 2x plus 1 over 3 as a single fraction if you want to, but I'm going to just leave it like that for now, okay? All right, that's my second piece. Third piece. Well, this third piece is flat. And flat functions are constant functions. They have a slope of 0. So they're like, it's like saying 0x, and it's on the line positive 3. Y equals positive 3. So that's like saying 0x plus 3, because it has a slope of 0. Well, 0 times x, that's 0. So that's gone, and it's just positive 3. So the function itself is just the function 3. F of x equals 3. So I'm going to put a 3 here with a comma. I only have one piece left to identify. All right, this last piece, let's look at that. It goes from here to here. Well, it looks like I could do this one graphically, right? My slope is going down 3 and over 3. So down 3 is -3, forward 3 is a positive 3. So that means my slope is -3 over 3. That's -1. So it's going to be -1x. But we don't write the 1 when it's a 1, so it's just -x. -x. And now, in this case, watch this. This is actually going to be kind of cool. I can follow this up. If I continue this line, I can continue it all the way to the y-axis. I'm just doing this as an alternative to point slope form. And if this line continued, this is where it would cross over the y-axis. So that's at 1, 2, 3, 4, 5, 6, 7, 8, 9. So the y-intercept of this line is positive 9. So I can just put a plus 9 here. And now what I have done is I have just written the piecewise function of a given graph. And that's something that you have to know how to do. If you can do that, and if you can take a piecewise function and graph it, you are in really good shape in terms of understanding graphs, or at least linear graphs for now, and in understanding piecewise functions. This will allow you to move further and understand more complicated things that we're going to talk about in the next video. Okay? Well, this was good, and good luck.